in this section, what we want to try to do is learn how to graph some of these polar expressions, these polar equations that we have here. And so we're going to kind of have to get our mindset off of squares or 90-degree angles that we see in the XY world. And in the polar world, we're going to see grids that have concentric circles built on up within that particular grid. So this should look familiar to you. It looks roughly like the unit circle with several concentric circles. And I've marked off around the outside of the circle the significant radians that we've come to kind of know and love and see repeated over and over again. So let's work through a process here and see how we can graph a particular polar equation. The equation that we want to graph is the graph r equals 4 cosine theta. And let's see what it does and what it looks like. So what I'm going to do is I'm going to build the basic radius theta table. So if I want to know what my radius is, and then I'm going to put a theta over here because I'm going to put in some work here in the middle. I want to figure out what some particular points are. So what we're going to do is we're going to plot points, just like we've done before. But in the XY world, we always like to plot x equals 0, x equals 1, x equals -1, and so forth. And so in polar world, we're going to plot different radians. And we don't have to plot a lot, but just enough to get to an idea what the graph looks like. So I'm going to plot marks at 0, and then I'm going to work my circle around every pi/6 of a move. So pi/6, pi/3, pi/2, 2/3 pi, 5/6 pi, and then pi. So we'll just start with that. We'll see if we need some more points, but those are some just generic basic points that we can choose. Again, you can choose whatever points you want to or whatever ratings you want to. And with more practice, you'll start to get a sense of maybe which ones will be better choices than others. Just like in XY world, we learned that -1, 0, and 1 were great choices. We didn't think so at first, but after practice we did. In polar world, we're going to look at some of these beginning radians to get an idea. So let's look at this one. Oh, sorry. I did that table backwards. I didn't. This is my theta. You guys saw that, didn't you? And that's what my r was. Had that a little backwards. Sorry. So if theta is 0, I'm going to look at 4 cosine of 0. And what does that equal? Cosine of 0 is 1. 4 times 1 is 4. So I have 1 point all ready to go. Pi/6. 4 times the cosine of pi over 6. Cosine of pi over 6 is √3 over 2. So that's 4 times √3 over 2. That equals 2√3. And that's approximately 3 point, what did my calculator say? 3.5. Pi/3, I'm just going to choose that one as my next radian. So let's put in the equation here. 4 times the cosine of pi over 3. Cosine of pi over 3, 1/2. So that's 4 times 1 over 2, and that equals 2. Pi/2, 4 times the cosine of pi over 2. Cosine of pi over 2 is 0. 4 times 0 equals 0. 2/3 pi. That's 4 times cosine 2/3 pi. 2/3 pi was 1/2. So it's 4 times 1 pi. I have to remember mine as well, is 1/2. And that equals 2. 5/6 pi. 4 times the cosine of 5/6. Oops, sorry. That is -1/2 equals a -2. And then cosine of 5/6 pi, 4 times the cosine of 5/6 pi is root 3 over 2, negative. That equals negative 2 root 3, or approximately negative 3.5. And then my last one was pi. 4 times the cosine of pi equals 4 times the cosine of pi was negative 1 equals negative 4. So from there now I have a set of polar coordinates that I can go ahead and start to gently draw a graph on and see what these particular points look like and where they're at. Draw this in 0. And look at this one. So the first one, if I have a degree of 0, and then my radius is 4. So up 0, that's right there on the polar axis. I have a point right there. You guys all right with that? Okay, the next one is we have a radius of pi/6. That's this radius, or this angle right there, of pi/6. And I want to go out a radius of 3.5. So 1, 2, 3, and roughly right there, about there, 3.5. The next one we looked at is theta of pi/3. That's this one right here. And I have a radius of 2. So pi/3, 1, 2. There is such. I know my polar graph, there's hard to draw very clear concentric circles. And so my graph will kind of look a little skewed a little bit. But I hope you get the idea. All right, pi halves. I'm going to look at pi halves. That's up this radius. And then my radius is 0. So that's right there on the origin. So we got 4 points so far we're plotting. I am looking at 2/3 pi. So if I look at 2/3 pi, it's this radian right here. But notice that my radius is a negative 2. So I'm pointing that direction, but I'm going to go backwards 2 spots because I have a negative radius. Yep, that's on the right one. 5/6 pi. 5/6 pi is this direction, but it points me back out a negative 3.5 instead. So I have a negative 3.5 roughly right around there. And then at pi. Pi in this direction, the r is negative, so it goes backwards, and there it is, it's that same point. And now it looks like that if I continue around the circle, the points are going to repeat themselves. So now what I'll do is I'll just start to gently fit a curve that fits all these points. So it looks like I have a circle. R equals 4 times cosine theta. Looks like I have a circle situated here, and it looks like maybe the center is at the point 2 and 0, which we can go ahead and verify. And so let me see if I can verify where that's at correctly. So if I have R equals 4 cosine theta, a great way to verify that is send it over to XY world. And so doing that, I'm going to multiply both sides by R. R squared equals 4 times R times cosine theta. R cosine theta, do you remember what R cosine theta transitioned to in XY world? Just an X. So I have R squared equals 4 times times X. R squared was itself an X squared plus a Y squared equals 4X. Subtract 4X from both sides. If you remembered a little bit from one of the examples we did a couple of videos ago, we're starting to see that this is moving towards the equation of a circle. So in order to do that, I'm going to need to complete the square. So I'm going to add 4 to this side, add 4 to the other side. X squared minus 4X plus 4, that is X minus 2 squared plus Y squared equals 4. And there I have a standard equation of a circle where I have the center of the circle at the point 2 and 0. And that verifies that I have, or the center point of that circle is at the point 2 and 0. So that was a little bit of a process of working through how to graph a particular equation in polar world by plotting some points. And the points we're choosing now, rather than a specific X or Y, we're choosing specific radians and then figure out what the radius is and then building a smooth curve around that. And throughout this section, we're going to start to become comfortable or at least get introduced to some reoccurring polar equations and their graphs that we'll see kind of pop up once in a while.